Okay. Hello everyone. Welcome to 7 Peaks and thank you for coming today. And it's great to see you here and it's great to see yourself and South. Yeah. And it's been a while we don't see each other in person, but we always here organizing webinars to sharing interesting topic and interesting knowledge to social days. Yeah. And yes, and it's great that we can organize meetup in line with safety regulations and social distancing. Yeah. And for someone might know who we are, but someone not might know who we are. Yeah, 7Peak Software, we are software design agencies based in Bangkok, and we are started in Norway since 2004, and then we relocate the headquarters to Bangkok since 2014, and then we are in Thailand more than 7 years nowadays to helping Thai local clients and also international clients. It's easy to find out. You can click like and follow us on social media channels on Facebook and LinkedIn to know more about us. And we will always updating the upcoming events and another webinars and update about the activity internals and also job posting, job opportunity in here. We are work harder and party harder also. This is some of picture of activity in indoor and outdoor activities. We are always organize activity to make people having fun. If you work at 7Peak, you will not good at coding at the same. You will good at everything because we have many activity for you. And we are also doing a lot of sport also. We have like gyms, e-sport in the office, and we are also have like interesting small group for interesting people. We have like badminton clubs also. And we are also eating a lot too. So every Tuesday and Thursday we will have like free lunch in the office if you came here. And occasionally we'll have like wine tasting sessions, barbecues, and many sessions in the office. And also we have like buffet beer you can drink unlimited. If you and your friends interested, we are also open in many positions such as like head of cloud and back end, head of product, front end developers, and those kind of these positions you can contact me or our team to send in the resume and got this job. Okay, so you can check it out about events or another webinars that you can scanning this QR code because we are always update and sharing about the information of company in here. Okay. Thank you for today, and for today we will talk about RXSwift and during the meetup. And I will invite the first speakers is Rupendra. Please.
Thank you very much for such a warm welcome. Good evening, everyone. Good evening to iOS Meetup. My name is Rupendra. I'll be talking about concurrency in Swift. Now, when we think about concurrency, the first thing that comes to our mind is what is concurrency? The dictionary meaning of a concurrency is a fact of two or more events occurring at the same time. In computer terminologies, concurrency is an ability of a unit of a program or an algorithm to run out of order without affecting the final order, without affecting the final outcome is very important. Just focus on these three words. These are the prerequisites for any concurrency to occur. Now, I'll give you a short demo about concurrency. What is concurrency? As I said, it's an event, multiple events occurring at the same time. And walking and talking at the same time, this is concurrency. Now, let's take a very simple example. I have this box full of candies. I need to transfer these candies to a ball. Now, what I will do, to have this task done, I will break this task into a simple steps. Pick up a candy, drop it in the ball. 1, 2, 3, 4, 5, 6. Done? Now this is a single approach. Now what about another approach? This time, I'll do it like 1, 2, 3. Done. Right? What did I do? The prerequisites of consistency. The decomposability of a program. The first thing, I decomposed my program into minor steps, picking up a candy, putting it in a bowl. Now the second thing is ability of parallel execution. This single step can be executed parallelly. I can take one candy and drop it in the bowl. I can take two candies, drop it in the bowl. The parallel execution. And the third thing is order of execution. Now, it doesn't matter in which order the candy is picked up and dropped in a bowl. The final outcome is going to be transferring all the candies from a box to a bowl. So that is order independent outcome. Now, why is concurrency needed? There are few advantages of a concurrency, and that's the reason we need concurrency. The first thing is minimize response time. If you see, when I dropped each and every candy one by one, it took me around 6 seconds. But next time when I picked up two candies, it took me around 3 seconds. So why did it come from 6 seconds to 3 seconds? Minimum response time with the concurrency. The second thing is maximize throughput. When I was picking up single candy, the throughput was a single candy. When I was picking up two candies, throughput was two candies. The throughput increased in the second time. That's a maximized throughput. And the third one is efficient resource utilization. Before I was just using my one hand to transfer candies from box to box. In the next approach, I used both of my hands, right? In the first approach, my left hand was just idle, it was doing nothing. It was there, it was just idle. So I did not utilize the resource even though it was there. In the next approach, I utilized that and transferred the candies and did the efficient utilization of resources. So these three are the reasons we need, these are the three needs that we should prefer concurrency. The next thing is solution. Which are the solutions provided for iOS to have a concurrency with? Apple has provided us 4 features which we can implement the concurrency. First is thread, second is GCD, third one is operation queue, and the fourth one is async subject, which is newly introduced. We'll discuss all of the 4 implementations one by one in the next few slides as well as in the demo. First, we'll go for thread. This is a simple implementation of a thread. Now, thread is a base class that gives us an ability to deal and manipulate the threads available on the operating system. This thread class is defined and declared in the foundation framework, so while using it, we need to import a foundation framework. Thread is available for our iOS 2.0 and onwards. This is a very basic class, and it can be used with an initializer passing block to it, or we can subclass the thread class and implement a main method to it. How do we start a thread? How do we actually perform our operations? We call a start method on that. But make sure that we have implemented a main method. If we are subclassing it, that method will get called when we call a start on a thread. You can also see something called as a thread priority. What is thread priority? Thread priority is a preference of a timely execution of a thread. Now this thread priority varies between 0 to 1. The default value is 0.5. But Apple documentation clearly says that this value is just a guideline. This value does not make sure that the priority that we have provided will be obeyed by operating system, because the priority of execution of a thread is decided by operating system on a kernel level. So this value, whatever we said, is a guideline to an operating system to ask a priority for our thread. Now, I'll show you how can we implement a simple thread. Now for this demo, I have considered a scenario wherein we need to upload an image to a server. Now for that, it will go with the 4 stages. First we need to fetch an image, then we need to resize the image, then we need to compress an image, and then we need to upload an image. When we are doing it, I have defined 4 different classes with the responsibility for each stage. Now this code just contains some dummy code. It is not implemented for full functionality, just for the demo purpose. Now these are the different classes. Those implement our functionality, but they don't care about the threads, they don't care about concurrency, they don't care about the background processing. The problem it creates that whenever we call these functions directly from, let's say, our view controller, view or view model, they will start executing on a main thread. And main thread is always utilized for UI updates. Once we start calling these methods, our UI will get blocked. And that's why we need to call these methods on a background thread. But these classes, they are implemented without considering concurrency. Now what to do? For that, I have implemented a different classes, kind of manager classes, to handle concurrency. Now this is a thread manager I've implemented that will take care of actually performing the process as well as giving us a callback from a caller function. Now what is callback? Callback can be any piece of code that will get called once the feature or a functionality or a block of code has been executed. So once your asynchronous task is done, it's your responsibility to call a callback and give caller an information that you are done with the task. Now this callback may be simple void, it won't take any details, and it can also give us some result that can be utilized in a caller function. For this, I have used a result enum. What does it do? If we are fetching an image, the result will be expected as an image, and then an error in case any error occurs. This enum helps us keeping track of it. Now, how do we call this method? You see this? This is actually the implementation. You see, this is very complex, and this is called as a callback hell. If we have multiple steps in performing our code, we will get to have something with the indentation and a block inside a block, which is referred as callback hell, or it can also be referred as a pyramid of doom. We'll discuss about that later in a few of the slices. Now what are we doing here? We have initialized a manager. We'll just call a fetch method with a completion block, and this is our result. If we get a success and an image, we'll use this image as an input for the next stage. In case of failure, we'll go in the failure case and display result to a user. As the final result is available, we'll display the success message to a user. Now, this is a very crucial stage. the caller thread. What is it? Caller thread is something on which your function is getting called. Now, many people make this mistake of calling a callback from a queue or from a thread on which it is getting executed. What happens if you are running something in a background and you are calling a callback on the background thread? Your caller function might be from a view controller, will still be getting called on the background thread. And if you are updating any UI in that, your application will get crashed because you are updating a UI from a background thread, which should not be the case. So that's why we'll need this caller thread. Most of the times this will be a main thread, but there is a condition, there might be some scenario where your background function or background thread is called from another background thread. So it is very important to give a callback on a caller thread. Now I will just run this, make sure this is for thread. It is running. Now this is a slider. I'll just run it again. Look at this log. The log specifies that the process is actually running and we are getting an output. So I can still slide the slider. When the alert came, it was in the UI thread, so no crash. This is about thread. You're getting a callback on a main function, main thread, and nothing is getting crashed. The next thing in the discussion is GCD, is a Grand Central Dispatch. The Grand Central Dispatch it was implemented in C, so it is available on C, C++, Objective-C, and of course Swift wrapper was implemented and released later with the Swift. Dispatch queue is available from iOS 8 and onwards. Dispatch queue does not give you a direct access to threads. It just gives you access to queues, and the threads will be managed by each queue on its own. This is just a simple code. It shows how to access a global queue with something called the QoS, and an async function is called on it, and final a callback is given on the main queue, which is again in async, and we will be printing some success message in here. The code in the below that specifies us how to create a custom queue. We'll have to provide a label, a QoS, and an attribute which can be concurrent or serial queue. We'll discuss this in the next slide. The queue types. Queue types can be defined on different criteria, one of which is creation and access. The first one is main queue. It is given to us by Apple. It always accesses main thread. So whatever we have to do related to UI, we have to do it on the main queue. The next one is the global queue, which deals with the background threads, and it is also provided by Apple. If you look in the previous slide, it will show you how to create a global queue as well as a main queue. The third one is custom queue. For this, you have to provide a label and few of the parameters like QoS and other attributes. Another differentiation for the queues is based on execution. It can be a concurrent queue or it can be a serial queue. Serial queue is always a main queue in which the tasks will be executed one by one in a serial order. Concurrent queue is something in which the tasks will be executed at the same time in parallel. It will be a global queue. So the global queue that we have in the first differentiation, that is actually a concurrent queue. And in case of custom queues, we can provide the attribute as concurrent or serial to have different types of queues. We can pass QoS, which we will discuss now. What is QoS? It is quality of service. Do you remember we saw something like a thread priority during the thread implementation? We can relate it to this one. There are 5 types of QoS provided by Apple. First one is the user interactive, which is the highest priority. Then we have user initiated, which is high priority. Then we have a default, which is like a medium priority. Then we have utility with low priority, and background where we have the lowest priority. We have to consider that the background priority or the background QoS will be used when we have a task that might run for a few minutes to hours. It's like an indexing, or we have to gather some metadata from our system and store it in the storage. For that, we can use the background QoS. Utility queue can be simply used. Utility QoS can simply be used for the functions like API calls or file writing with a small size, updating some data. That's all. The next thing again is demo. Now, interesting thing about the threads, GCD, and operation queue is that there will always be a callback. If you look at this code for a GCD, it is still having the completion calls. The callback hell is still there. How to resolve it? We'll come to that. Now, the image manager in GCD takes care of a caller queue. In this case, we have to focus on the caller queue because we have to provide a callback in the caller queue. If I run it, the GC is executed, UI was not blocked, the final outcome came on the UI, so it is still waiting return in the UI thread. This is a simple implementation of GCD. I'm using the global queue with a sync implementation. The parameters can be a completion block and a caller queue. Nothing is operation queue. This is a bit advanced than thread and GCD. How? It provides you the functions like cancelling, it provides dependency handling, and it is easier or more object-oriented to implement. Now for operation queue, we have an operation class. Operation class is an abstract class. Apple has provided us two concrete classes with the implementation. They are the block operation and invocation operation. We can also subclass the operation class on our own and implement a method main. Now, do you remember when I said we have to call a start method for a thread to execute? We don't have to do anything like that for operation. We just have to add the operation on the operation queue and it will start executing. The only thing that it will wait for is the dependency. Once all the dependencies are met for an operation, the operation will start executing. This is a simple code for implementation of the operation. One is the block operation. It takes the block in the initializer, and the other class that we can implement where we have to override the main method. Initialize the operation class, add it in the operation queue. We are done. Operation queue is available from iOS 2.0 and onwards. States. As I said, when we start an operation, there is something called as a state of an operation that is defined and available as the state of an operation changes. The four stages are ready, executing, finished, and cancel. When operation is actually ready to execute, that means all the dependencies of an operation are finished, the resources are available, it will be ready to execute. Executing state will happen when actual operation is executing. So once we add it on the operation queue, it will start executing. The executing state will happen. The next thing is finished. When operation has finished all its tasks, it will go into a finished state. And when user or programmer cancels the operation by calling a cancel method, it will go into a cancel state. These are the four important states of an operation queue. Dependencies. Consider a scenario when you need to upload an image, but the catch is you have to compress an image before uploading it to a server. Now there is a dependency of compressing an image before uploading it. how to handle it. This is where the dependency comes into picture. First, we create a compress operation, we create an upload operation, and before adding them to queue, we have to specify the dependency. So upload operation will have a dependency of a compress operation. So once they are added on the queue, the upload operation will wait until the compression operation has finished. And the last statement, which says wait until all operations are finished, it will just wait for all the operations are finished, as the name suggests, nothing else. Cancelling of an operation. This is a very crucial part when we are actually dealing with the operation queues. Many people think, okay, first of all, how to cancel an operation. We have to call a cancel method on an operation, or we can simply call cancel all operations in an operation queue. When we call these methods, what happens? It just says as if cancelled parameter, is cancelled property of an operation to true. It does nothing else. If you think that just calling a cancel method will cancel the operation, that is not correct. We have to implement a code to actually cancel the operation on our own, and that's why we have implemented check for self.isCancelled, break or else print the switch statement. This is very crucial because if you think that just calling a cancel method on an upload operation will just clear the queue and stop the uploading operation, that is not going to be a case. Consider you're downloading some file in say 2 or 5 GBs. User wants to cancel, he clicked on the cancel method, you call the cancel method in an operation and thought the operation is cancelled. But in the background, it is actually still consuming the data, downloading the file. We have to kill that thread, we have to stop the downloading operation on our own. Now, came the demo part. Now this is a simple implementation of operation queue. Again, we have a caller queue, we are having a block operation, we are executing the tasks in the background, and we are giving the callback on a caller queue. This can also be implemented. Let me just show you if the UI is blocked. No, functions are getting called. This is again on the UI thread. Now this also can be implemented. We have the 4 stages, right? First, what we're doing, fetching, resizing, compressing, and uploading. We can implement all these implementations with the operational dependency, but in that case, what we have to do is we have to take care of all the deadlocks, we have to take care of race conditions, and that makes it more complicated. And that's why it's always preferred to have a callback method and implement the operation queue. And that will again obviously lead to a callback here. Now this is the solution for a callback here. This is something new implemented in Swift. It is available from iOS 13 and Swift 5.5. The async await feature gives us the ability to implement structural concurrency. Now, async and await, these two are the keywords. They work hand in hand. The async keyword suggests for any function that it is implemented and it runs in an asynchronous manner, and we have to wait for its return value to be available. And that's why any async function has to be preceded or has to be called with an await keyword. The async keyword can also be implemented with a try and catch, but while we are calling it, try has to precede the await and async has to precede the throws. The return parameter will be available for any of the method as usual. Now, what are the advantages of async await? The first thing is avoid callback hell. As we saw in all our implementations, the indentation was too much. We are having a callback. We had to check all the features, all the results, or the error scenarios. We don't need to do that in async await. The callback hell or PWF2 does not exist in case of async await. The second thing is less number of lines of code. I'll show you again in the code. If you see, when we are having a thread, it takes this much code lines. In async await, reaches these many lines. The color function has this much implementation, but when we go for async await, it reaches this much. We'll see that when the demo part comes. The next thing is improved readability. As there is no callback, obviously there will be a lot of improvement in the readability. The last one, which is the most important, is guaranteed return. What happens many times when we are having a callback functions, we miss some scenarios. There is some error case, there is some if-else condition, there might be a switch case where we forget to call a callback. Whenever we, let's say, press a button and we are expecting something to get called back and run the next stage, it doesn't happen because we missed to give a callback to a caller function. And we think that the program is hacked. But in the reality, what happened was we just missed a callback. And this will never happen in case of async await because it's a return feature. If you see in the code, the data is returned. So unless and until each and every block of your code returns something, you'll get a compilation error. Your code will not compile. And that's the advantage of async await. We don't have to take care of calling callback and making sure the callback is called from each and every condition. Let's go for a demo. Now, in previous scenarios, what we saw, once the image is fetched, it will be used as an input for the next stage. So we have to have that in a callback. We have to get that result, handle the conditions. We don't have to do that in here. We just have to call a fetch image. It will return a fetched image. It will be directly input for the next stage. It will give the resized image. The resized image will be an input for the compressed image. The compressed image will be input for upload image. We don't even have to take care of the handling error cases and everything because we are using try and catch block. If some kind of error happens, it gets thrown, we can catch it in the catch block and handle it as an error condition. But there is a catch. This thing. When we are implementing any of the async functions, we can't simply call it from any of the functions that we currently have. Because let's say we have view controllers, we have views, we have view models, we have any subject classes. All these classes, they don't support concurrency. So if we have a view reload and from which we are calling some asynchronous class, it will give you an error because you are entering into an async mode from a current implementation of Swift. And for that, we have to have a task, which can be a detached or it can be a main thread task. We have to implement it. And once you have implemented it, you can implement any async code inside it. And after that, to give a callback on a main UI, now why is it in the background? Because it is a detached task. If we just create a simple task with a constructor, it will be a main thread task. And we have to give a callback on the main thread again. Now in this case, there won't be any thread, there will be an actor. Now actor is a new functionality introduced by Apple. There is also a keyword actor, which is a reference type in Swift. But this main actor is actually an implementation of a global actor. See, this is an actor, a main actor, which is an implementation of a global actor, which is a protocol intent defined in here. You can see the availability iOS 30 and above. So with all these implementations, we can go for async await. As I discussed, it will save you a lot of headache of implementation, but the limitation will be you can't use it before iOS 30 and it won't be available if you are not using Swift 5.5. There are some workarounds against it. You can have an availability clause implemented. You can have two methods implemented. If the async await is not available, you can have availability clause to check and go for the old method. And if async await is available, you can implement that. But that again will be an overhead to call the features. And obviously you have to invest more time in implementing both the roles. So that's all about the concurrency. You guys have any questions? No? I think we are all good then. Thank you very much for listening. Thank you very much for your time. Thank you.
Please welcome the next speaker, Tu.
Good evening, everyone. It's my pleasure to welcome you here. I am Saravudh, senior iOS developer at 7Peak. Today, I'm going to talk about subject and operator in RXSwift. Okay, thank you. Today, I will talk about subject and operator in RXSwift. My talk will be in 3 parts. First, I will recap about RXSwift. Next, I will talk about subject. And finally, I will talk about combining operators. And after my talk, there will be an opportunity for discussion and any question. So, what is RXSwift? RXSwift is a library for handling asynchronous tasks. There are 3 main components in RXSwift. First, observable. Observable is a response for produce an event. Event can be one of 3 things: data, complete signal with success, and complete signal as an error. The second component is observable. Observer can receive event from observable, and you can put some business logic here. And final component is operator. You can add operator in between observable and observer to manipulate data before pass it into observer. Let's move to the subject. Subject is observable that you can add an input at runtime. We will start with public subjects. Public subject is commonly used in RXSwift application. When it receives an event, it will directly emit the event to their subscriber. A top line is represent a subject. Middle line and the bottom line will represent the observer. So we will start with, we will create the subjects first, and then we subscription one to the subjects, and we put red into the subjects. Red will be emitted to the subscription one, and when we put green will be emitted to the subscription one. Next, we subscribe subscription to the subjects, and we put blue. Blue will be emitted to subscription one and subscription 2. I will translate this into code. It will be easy for understand. First, I create the subjects. Then I create subscription one and subscribe to the subjects. And after it receives the event, it will be pinned out to console. And then we put rate into the subjects, and rate will be emitted to the subscription one. We put green into the subjects. Green will be emitted to subscription one. And we subscribe subscription to the subjects. And we put blue into the subjects. Blue will be emitted to subscription one and subscription two. Next, we will move to the behavioral subjects. A difference between behavioral subjects and public subjects is when you subscribe to the behavioral subjects, you will get an item immediately. First, we create public subjects with a purple item, and next we subscribe subscription one to the subjects. At this time, subscription one will get the purple, and we put red into the subjects. We put green into the subjects. Green will be emitted to the subjects. We subscribe subscription two to the subjects. At this time, it will receive green because green is the recent item on the subjects. And we put blue into subjects. Blue will be emitted to subscription one and subscription two. Okay, next we will translate it to code. First, we create behavioral subject. Then we subscribe subscription one to the subject. At this time, it will print the purple out to the console. We put red, subscription one will get red. We put green, and we subscribe subscription to the subjects. Subscription 2 will get the green. And then we put blue. Subscription 1 and 2 will get the blue. The third subject is replay subjects. Replay subjects is come with a buffer. When they emitted the item, they will keep the item that were emitted and send it to all subscribers when they subscribe it. First, we create the replay subject, and we subscribe subscription one to the subjects. Then we put red. Red will be emitted to the subscription one. We put green. Green will be emitted to the subscription one. And next we subscription to the subjects. At this time, they will get all of the items that are on the subject, that is red and green. So they will get red and green. And then we put the blue into the subject. Blue will be emitted to subscription 1 and subscription 2. We put complete event. Complete will be emitted to subscription 1 and 2. Okay. First, we create replay subjects with buffer size 3, and then we supply subscription 1 to the subjects. We put red. Subscription one will get red. We put green. Subscription one will get green. And we subscribe subscription 2 to the subjects. Subscription 2 will get red followed by green. And then we put blue into subjects. Subscription 1 will get blue and also subscription 2 will get blue. The last subject is async subject. Async subject is a simplest in RXSwift. It will emit only one last item to their subscriber. First, we create a sync subject. Then we subscribe subscription to the subjects. We put red into subject. We put green into subjects. Nothing will emitted to subscription 1. We subscribe subscription to the subjects. Also, nothing will be emitted here. We put blue into subjects. Nothing emitted here. And after we send the complete event, the blue will be emitted to subscription 1 and subscription 2, followed by complete event. On the code, we create a sync subject. We subscribe subscription 1 to the subject. We put red, we put gray, nothing will be printed out to console. We subscribe another to the subject. We send blue into subject. Then we send complete. Blue will be sent to subscription 1 and subscription 2. Okay. Let's move to the final part today. Combining operators. Combining operator will work with multiple source of observable to create a single output observable. We will start with merge. Merge operator will merge all of items from input source and send it out to output observable. Let's see on the diagram. The top and middle line is represent source of observable, and the bottom line is represent output of merge. First, we send 20 to input 1. 20 will be emitted to the output. We send 40. 40 will emit to output. We put 60. 60 also emitted to the output. And then we put 1 into this input 2. 1 will emitted to the output. And also the same. It just merge every item into single output. Let's have a look in the code. At first, we create input 1 and input 2. And we create output for merging input 1 and input 2. And we also subscribe to the output. After output emit something, it will be print out to the console. We put 20 into input 1. And output will get 20 and will print it out to console. We put 40 will be printed out. We put 60, we put 1 into input 2. We put 80, we put 100, and 100 will print out on to console. Next operator is combining latest. Combining latest is will combine item from several inputs together and send it out to output as a pair. Let's see on the diagram. When we put one into input one, nothing will be sent out because we have nothing here, and then we put A into input 2. At this time, we have enough item on input 1 and input 2. So we will pair it together and send it out to output. And when we put the 2 in the input 1, it will be combine it with the latest item, that is A. So it will be 2 and A. When we send B, it will be 2B. And this time 2C, something like that. We will see in the code. First, we create input 1 and input 2. Then we subscribe to input 1 and input 2. And when we get the data, we concat the input 1 and input 2 item in the single string and print it out to the console. We put 1 into input 1. We put A into input 2. At this point, output can emit the item because it has enough item for input 1 and input 2. So they will print 1A to the console. When we put 2 into input 1, 2A will be print out to console. We put B, 2B will print out to console. We put C, 2C will be print out to console. Yes, it do the same thing. The final operator is shift. Shift is quite similar to combine latest, but it will not emit an item that was emitted. So let's look at the diagram. I will explain it. When we put 1 into the input 1 and we put A, it will emit 1A. And at that, we put 2 into the input 1. Nothing will be emitted here because A is already emitted. So we need to wait item from input 2. When we have B into input 2, they will send it at 2B. And C, when we put C here, nothing here, so it can not emit any item here. We need to wait item from input 1. We put no item from input 1, and once we get 3 in input 1, it can emit 3 and C into output. So same as 4D here. I will show you in the code First, we create input 1 and input 2. And for output, we stripping the input 1 and input 2. We put 1 into input 1. We put A. 1A will print to the console. And right at this time, nothing there are nothing on input 1 and input 2. When we put 2 into input 1, they need to wait an item in input 2. We put B. At this time, they have enough data, so 2B will be printed out. We put C. There are no item in input 1, so nothing will print out. We put D. Is also nothing in input 1. When we put 3, there are 3 and the first item in the input is C. At this time, C and D are on input 2, but they sit it with 3 and C. That is the first item in the input 2. Put 4, then we emitted 4D. We said complete. And when we put D, nothing will be printed out because they get complete signal already. Okay. If you have any question, I'd be happy to take them now. Okay, let's move to the next part.
Let's start. Good evening, everyone. Today I'm excited to share how you can get the better performance out of your application. My name is Watanashai Witagun, and I am a senior iOS developer here at 7 Peaks Software. I have 8 years of experience in various e-commerce systems, including video streaming, entertainment, and healthcare applications. I will break this talk into 3 sections. The first, starting with an overview section that will help you understand the basic key metrics to indicate your application performance. Then I will talk about the tools and SDK provided by Apple. It's called the Metric Kit. It will help you aggregate and analyze the report on exception and crash, diagnostic, and also the performance metric. The Metric Kit is available since iOS 13, but for now in iOS version 15, there is a lot of improvement, and I will talk about that in this session. The next session is about the hangs in your application, starting with understanding what is the hang, and then I will talk about the common causes for hangs. After that, I will show the tools that you can use to monitor and diagnose the hang. And finally, I will share the common practice to eliminate hangs and how to choose the solution that works best for your app. And the last section is the demo. Okay. Let's jump right into the first section. If you want your application to be the best, your application needs to be fast and reliable. I have recently seen a large number of clients facing problems with their application performance. Many applications run into the performance problem as they grow. How to start and what should be the first? There is always something that you can do if you have the knowledge and the motivation. The real trick is knowing where to look for the performance improvement and what step to take first. What step to consider when doing the performance improvement in your app. Modern applications are getting increasingly complex and they process the huge amount of data and communicate with the external system, many systems. It became an engineering nightmare. Some applications need to be re-engineered from the scratch to solve this performance problem. So, if you are building the new application, performance work should never be left at the end. The larger and more complex your application, the earlier you need to start to focus on the performance improvement. The performance of any app is crucial for the user engagement and retention. When an app grows, more feature get adds and more feature app size increase and external dependency increase, it is essential to audit the impact of those changes to continuously improve the performance. Continue to optimize your application performance will make your user use your app more often and stay more engaged and will use your app for the longer period of time. This session will help you understand tooling, metrics, and paradigm that will help you smooth out your development process and contribute the great experience for the people using your app. Okay, let's take a look at the different performance metrics that I will cover today. It will be 8 things. There are currently 8 key things to track the performance in your application. The first is the battery usage and launch time, hang rate, memory, disk write, scrolling, and termination. And the last thing is the wrapper API called NX signpost. Apple automatically collects this metric. No code changes are required in your project. Apple gathers the usage data from the device, consolidate it, and send it to the Apple server once per day in iOS 13 and 14. But for iOS 15, it sends almost immediately. These data are analyzed at the server and consolidated data is presented in the Xcode. First, let's talk about the battery usage. If your app running a lot of battery, this is what the user will see on their end. This is called the battery UI on the iOS. It shows user how much of their overall battery drain on the device, as well as the foreground and the background activity. Why should you care about improving battery life? Because users prioritize to using the apps that allows them to use their device throughout the day without needing to recharge it. By optimizing for battery life, users can use their device and your app for the longer period of time. There are many different subsystems to pay attention when it comes to optimize the battery life. The top 3 subsystems are the CPU, networking, and the location service. I can track the battery life of my app using a few different tools during development or after a version has already released. While I'm developing and testing a new feature and run my code through the Xcode, I can click on the debug navigator in the Xcode to see the various information that Xcode offers. The one that I will pay attention now is the energy gauge, like this. The energy gauge allows me to track my CPU usage and the CPU weight overhead. The high CPU utilization, that means when CPU usage is greater than 20%, And CPU wake overhead is the area that CPU wakes from an idle state. It's common to see the spike in CPU usage when my app is drawing the user interface, processing data from the network, or perform the calculation. But when those tasks are completed, my app is waiting for the user to perform their next action. I should see the CPU usage at near zero. The second metric is the launch time. Launch time is the amount of time when user taps on your app icon in the home screen and until the first frame gets rendered in your app. If your user spend a long time waiting for your app to launch, that can lead an unintentional frustration for the user, and extended launch time can lead the system to terminating your app. When the system terminates your app, and your user will experience the launch from the beginning, which takes much longer than resuming from the background state. Looking at the launch time in the Xcode organizer will give me an idea of what is the average of time to first frame in your application in the last 16 version, as you can see. So I can see how fast it was before my new feature was added. The next metric is the hang rate. A hang is when the application is unresponsive to the user input or action for at least 250 milliseconds. Hangs in the app can lead customer to force quit your application. In case of hang, in iOS 13 and 14, Metric Kit would deliver this hangs diagnostic data to me at 24 hours. But in iOS 15, I will receive all of this diagnostic data, including hang rate, in my app immediately after the issue happens. Using this instant diagnostic in conjunction with my own telemetry, I can quickly find the root cause of the problem. And I will explain this topic in the hang rate in more detail in the next section. Okay, the next one is the memory usage. Memory is a shared resource between the app, the OS, and the kernel. If your app exceeds the memory limit, it will be terminated by the system. And the next time that user goes to launch it, it will launch from the beginning, which takes much longer. If the memory usage gets too high, there is a chance that your app can get terminated for exceeding the memory limit. So I should keep an eye on this, the memory metric as well. The next metric is the disk write. Writing to disk can wear out the user hardware, which will lead to poor device health. And this write also take a lot of time and can lead to poor user experience and slow performance if done frequently. So it is important to monitor it. The next metric is the scoring. The problem in scoring occurs when a new content is not ready for the next screen refresh. This will lead to an unenjoyable user experience, resulting in user spending less time in your app. And as an app developer, the goal is to maximize the amount of the user engagement. So this is a great place to start optimizing. In case of scrolling hitches, iOS 15 introduced a new API, which is Metric Kit, to tag custom animation using MX signpost, which is a wrapper API that allows me to mark the critical section in your code, which I will show you later in the demo. And the next metric is the termination. The process exit can happen for many different reasons, such as exceeding memory limit or timing out on launch. Every time your app terminates for one of these reasons, it goes to the full launch flow in the next time, and that's not only take time, but it's also a terrible experience, especially if it's happening frequently. If the app does not restore the state before termination, this also adds to the frustration of the user. They need to find their place again or need to recreate the lost work, which is not good. Okay, the last one. I will talk about the wrapper API called MX signpost in metric kit. If you want to process this metric at your server, or you want to use the MX signpost API to measure the custom interval in your app, you may need to integrate the metric kit framework by import the metric kit and subscribe to the MX metric manager. And last thing is implement the MX metric manager subscriber to receive the consolidated data. Yeah, and after integrating the SDK, you can also simulate the payload by going to Xcode debug menu, which I will show you in the demo as well. Okay, the second main topic for today is about the hang rate. I intended to choose one of the interesting topics to explain in more detail. So today I will talk about the hang rate. What is the hang? Yeah, this experience can be described as laggy or unresponsive or spinning. We call this period of unresponsiveness as a hang. A hang is when the app is not responsive to a user input 250 milliseconds. Yeah. Hang is the app can lead customer to force quit your application, and it is major obstacle to the user's experience in your app. Okay. By eliminating hang, your app will be smooth, quick, and responsive, which is better, always better. What can cause hangs? So the first one is proactively doing work or perform the irrelevant work on the main thread. Yeah. So keeping the main thread busy for a longer period of time will cause your app to hang. For example, you have the table view like this, and the table view is only displayed 4 images out of the 1000 images. If the main thread needs to load all images at once, it will spend time on reading, preparing each and every image. So most of the work that's happening does not affect what a user perceives. One more cause for hangs is using the suboptimal API. So there are many ways to accomplish the task. Be sure to read the API document so you can use the best one. For example, to add the rounded corner for the image, we can use the bitmap context image like this to convert that image to the bitmap. Then apply the UI Bezier part on it. Then convert it back to an image. This set of operation is CPU intensive. It uses a lot of memory and also take a lot of time. This is because the wrong hardware is being used for the job. Instead of using CPU like this, which is the not optimal, we can use the GPU instead by using the core animation method on the layer. Adding rounded corner is easy and instant. This is just one example of using the suboptimal and optimal API for your job. Next, the synchronous API. Synchronous API can cause a hang as well. If the API does a lot of work or has the potential to block for a long period of time on the main thread. Apart from delay, this is also at the additional point of failure. In the main thread, if an app made the synchronous request to the network for the Wi-Fi or the 5G connections, there may not be any delay. But for the slower network speed, this may take longer. And for the very bad signal, this may hang indefinitely. There is no guarantee on this, which is why the synchronous operation should be avoided on the main thread. Another way to block the main thread is on the system resource on file I/O. File is the most commonly used system resource. Latency depends on the hardware, things that can be beyond the app control. So we need to do what we can to defend against hangs by avoiding the file I/O on the main thread. Yeah, the keyword is on the main thread. In order to diagnose a hang, You will want to know what your app is doing during that time. We can use the time profiler time profiler tools in debug navigator in Xcode to showing this will show your application call stack over time, indicating exactly what is executing while you are developing your app. But once your application has shipped, you can use the metric kit to collect the call stack tree as well. This enables you to prioritize the issue based on which issue that customers are most commonly hitting. When fixing hangs, it's important to baseline and quantify the performance of your app. The Xcode organizer does this by showing the performance metric, including a chart to display the hang rate per app version. Now, let's go over some common ways to fix that you can use to fix the hangs in your app. Each of these solutions can address multiple causes for hang. In order to know which one is the best for your app, you need to look at the side effect and the trade-off as well. To eliminating and defend against hang, you have to reduce the amount of work on the main thread. Yeah, as I said. This can be done in two ways. The first is optimize the work that already being done on the main thread. Reduce the execution time by using cache or the notification observer. By using cache or notification observer, or using the asynchronous API or the concurrency that the previous session was talked about, this can also fix the hang. Yeah. The second way is also move work off the main thread in a blocking manner, or use the GCD or the thread or the async awaits. Yeah. I will show you only one example of this. Notification observers are the way to reduce the work on the main thread. This allows your app to react to change in value or state. Any class can post a notification even in your own class. To find a notification from a specific class, check the API documentation. And to find all observable system notification, you can check out at the Apple developer documentation page for nsnotification.name. By registering observer for notification, the main thread no longer has to wait on querying the data. Once the notification comes in, the observer is invoked. To keep the main thread responsive, this update should be asynchronous. The most straightforward way to perform asynchronous is use the asynchronous API. Let's take a look at this example. Yeah. Number one, you move the work to the background global queue and run the work in the closure asynchronously. And second, number two, you add a new closure to the main queue, because anything that's modified UI must run on the main thread. And finally, you do the update fetch new images in the main thread. This is the feature of the GCD or the Grand Central Dispatch. Yeah, this is a powerful multi-threading mechanism which you can leverage in case where you want to move the work out of the main thread. The Grand Central Dispatch provides simple mechanism to avoid and to move any block of work to another thread, both synchronously and asynchronously. This makes GCD is very effective at eliminating most general causes for hangs. And finally, the last section will be the short demo. I will show you the source code and how to implement the custom logic of the metric kit. Yeah, please just for a moment. to my machine. I will show the source code. Okay, I will start with a simple project. I will run it to show you one more time. Yeah, there is the app that has only one table view to display the list of fruit and vegetable. Yeah, only this one table view. I will show you the metric kit integration. There are 3 steps to do that I just explained you earlier. The first is import the metric kit on the header here. And the second is add the MX metric manager initialization code that provided by the framework. Then add the table view controller as the subscriber to MX metric manager here. 2 lines of code. And the last step, add an extension that conforms to the MX metric manager subscriber on view controller. In this case, when receiving the payload, I simply print it to the console. However, in your production version, this is a good place to record the metric, such as making the API call here. Okay, next I will talk about the payload. You can receive 2 different payloads from the metric kit. The first one is MX metric payload. This is an object that encapsulates the common metrics that metric kit offer. I will show you the payload by clicking on the simulate metric payload here in the Xcode. But please remember, metric kit only works in the actual device. So I will send it to my actual device and I will print it into the console. Print this by uncomment here. I will show you the first one, the MX metric payload. Run the app. And I will simulate the payload. Let me close the simulator first. Okay, on the actual device, you will got the real metric kit payload. But for the demonstration today, I will simulate the metric kit payload from the Xcode. I will clean up this first. And I will run it again. Focus on the console. I will bring this up. Simulate the events. Yeah, there is a lot of data that metric kit sending to you. This value, I can see value that's scattered by device from the metric kit, such as the app version. Quite small, but the app version and the location activity as well. There will be lots of data in this payload. Okay, you can export it out after this. The next, I will show you the MX diagnostic payload, which is the payload encapsulate diagnostic data given by the metric kit as well. This payload will contain the crash and the hang that we are talking about in earlier. Maybe I can show you one time. Simulate the payload. Yeah, and we will see the hang diagnostic data or the crash. Crash data here. Yeah, it also contains the offset to memory or the address. So you need to simulation your IPA by using this data again after we got the data from the metric kit. But there is open source library that I'd like to share to you. It's called the Meter Reporter. This library helps us to capture metric kit payloads and relay them to the back end. But it does add some additional feature to support that you can check it out on GitHub repository. The last thing that I want to show you is manually logging the critical section in your app. So I can do that by add the MX signpost begin here. It will start recording the metric or the data for the telemetry here. And after you start, you put this code before the long-running operation, such as the API call or the CPU intensive task. And after you got the result, put the MX signpost in here. It will summarize the data and it can be sent to your server by using the MX signpost like this. There are a lot of features that Metric Kit offers for us, so you can explore it. And this is all for the short demo. I will go back to the presentation and conclude this session. This is a conclusion. After digging into all of those metrics and tools, I'm hoping that you are well equipped with the resource that you have to understand and resource that you need to ship the most performant application in the App Store. I recommend you to use the export organizer to see training data in your app, explore and play with the tools or the different templates that come with the instrument tool or the Xcode organizer. Yeah, so don't hesitate to get your hand dirty and explore all the tools that come with them. So thank you for joining me on today's sessions, and I hope you have a wonderful day. Thank you.